We're solving problem 15 from the 2026 AIME 1. Let a, b, and n be positive integers with both a and b greater than or equal to 2 and less than or equal to 2n. Define an a times b cell loop in a 2n by 2n grid of cells to be the 2a plus 2b minus 4 cells that surround an a minus 2 times b minus 2 possibly empty rectangle of cells in the grid. For example, the following diagram shows a way to partition a 6 by 6 grid of cells into 4 cell loops. Find the number of ways to partition a 10 by 10 grid of cells into 5 cell loops so that every cell of the grid belongs to exactly one cell loop. Now, what we notice here is that their loops are either horizontal or vertical. When they're vertical, a is greater than or equal to b, and when they're horizontal, b is greater than or equal to a, except for the one case where every loop is within each other. So this satisfies both. So we can say it's an outlier. So when we count the number, we have to subtract this since we count it twice. Now we notice that loops has to either satisfy 2 rows or 2 columns. And for this problem, we can denote parentheses as one loop. So if we have 5 pairs of parentheses in a row, where a pair of parentheses is one loop, this is 5 loops that are not within each other. They're all separate. However, if we have like parentheses like this, where they're enclosed in each other, this means that this is the case where all the loops are inside one another. So then we see that the insight for this problem is Catalan numbers. Now, the number we want to find is the 5th Catalan number because we want to partition a 10 by 10 grid of cells into 5 cell loops. So we have the 5th Catalan number is equal to 1 over 6 times 10, choose 5, which is equal to, when you calculate it, 42. And this is when we consider the vertical case. There are 42 ways for the vertical case, and then we multiply it by 2 to get the number of ways for a horizontal case. So we have 42 times 2 is equal to 84. However, we have to subtract one case where all the loops are within each other because we counted it twice. So then we do 84 minus 1 is 83 cases. So 83 cases is going to be our final number and our answer for this problem.